To give you an idea how the statistics calculator can be used to calculate binomial probabilities, I've put together this video and grabbed a sample problem out of the homework just so we have something to work out so you can see how the answers come about. To get to binomial distributions, you just hover over the distributions menu and then come down to binomial. And what you see here is a histogram representing a binomial distribution with some default values. You can change those default values of n and p, and you can change how the calculation is done. And what's also nice is you can really visualize what's happening with your calculation by sliding these 2 points here to different parts of the histogram. In addition, the mean and standard deviation of your binomial distribution is automatically calculated for any values of n and p that you enter. So there you don't even need the formulas for the mean and standard deviation of a binomial distribution. You get them automatically right there. So let's take a look at this example here. We have a local county has an unemployment rate of 7.7%. A random sample of 19 employable people are picked at random from the county and asked if they are employed. The distribution is binomial. Round answers to 4 decimals. All right, so starting with find the probability that exactly 3 in the sample are unemployed. Okay, so first off, we have to change some settings in the binomial program here. The number of trials is not 8 in this case. We have 19 people selected, so we set that. Now, if you enter 19 and you press enter, it's not going to change anything. It doesn't change until you press calculate. And let's see, P, the probability of success. So the probability that someone is unemployed in this county is 7.7%, which is 0.077 as a decimal. So just enter that. Don't worry about changing and updating these yet. Just go ahead and hit calculate so that the binomial distribution is updated. Now, the histogram that's drawn, if you'll notice, a lot of these columns here are really short. That happens a lot with binomial distributions. It's just part of how the distribution works. So that's okay. We have the information available to us to answer our questions. All right, so the first question is, find the probability that exactly 3 in the sample are unemployed. So this language of exactly 3, you want equals to 3. You know, the number of people in your sample that are unemployed to be equal to 3. So you could do it as a between probability, but it makes most sense as the probability that x equals a. This would be equivalent to using binom PDF in your calculator. And what's nice, you could type in 3 here and then hit calculate, and that's fine. Or you can just slide until you get to x equals 3. And either way, you'll get your probability of 0.1228, because it said that we wanted it to 4 decimals, so 0.1228 in that box. All right, now next, find the probability that there are fewer than 3 in the sample unemployed. So for fewer than 3, we could find the probability that x is equal to 2, x is equal to 1, and x is equal to 0, and add those together. But these other options already do these sums for you. So for instance, you could do all of them with the between. That's the most powerful of the ones, but these others are a little bit more efficient sometimes. So for instance, if we want fewer than 3, that's less than an item. So you actually do have you have the ability to move this, and look what happens. It shades in all of these. So what it's telling you is that the shaded ones are what are being added over here. So it's finding the probability between 0 and 2. And that's what we want, because it said fewer than 3, so fewer than 3 doesn't include the 3. So there we get 0.8237. So I'll put that in the box. Okay. Okay, let's try some others here. Find the probability that there are more than 2 in the sample that are unemployed. So more than 2, we want to get all of these boxes shaded this direction, which is this other direction here. So x is greater than a, that's more than. Now, sometimes you get funny things like this with NaNs happening. Generally what that means is, if you'll notice, the dot kind of disappeared. It's okay. Stuff like that happens on the refresh, and I'm looking to find those errors and get those fixed. But you can just type in a 2 and then hit calculate, and it will just reset everything and put the 2 in where it needs to be. All right, so we want more than 2. So more than 2 would actually be 3 or greater. So we want to go from 3 up to the maximum, which is 19. So all of these 2 items here are calculated as a between probability. And you could honestly do this as a between. It's just, like I said, a little more efficient without it. In the calculator, you'd be using like binom CDF, which is a little tricky to use. And these different options really make that quite simple. All right, so more than 2, which would be 3 to 19, that total sum is 0.1763. So that's the answer here. And find the probability there are at most 3 in the sample that are unemployed. So at most 3. Tell you what, at this point, I'm going to switch and I'm going to do a between. And if we want at most 3, we just need to change these points in order to make that make sense. So let's see. All right, at most 3. So we have a choice between like 0 to 3. And that sort of makes sense, because at most 3 sounds like it would be less than 3, but also including 3. All right, we have, an option of 3 to the maximum, but at most 3. This is what they're talking about. So you can't get any more than 3. 3 is your maximum. So 0 up to 3, that's what we want. So in this case, that's added up for us down here. 0.9464, that would be our answer. Notice you could have gotten it in this mode as well. And basically it just turns off this box setting. You're always doing a between probability with the minimum as the bottom. So either way, 0.9464, that is the answer there. Now, it doesn't ask in this question, but if it had asked for the mean and standard deviation of your binomial distribution, the mean is generally n times p. Not generally, it is n times p. So if you take 19 times 0.077, I'm going to switch over to the calculating mode to do that. So 19 times 0.077, that gives you a mean of 1.463. So that is the mean of our binomial distribution. And notice it's already calculated that for us. And whenever we update n and p, these automatically update too. The standard deviation, the formula for the standard deviation is the square root of n times p times q. So times, and I'll just do 1 minus 0.077, that's fine. Or you can compute what that value is first. It doesn't make a lot of difference. Either way, we get our standard deviation of 1.162. And if you'll notice in the binomial distribution, that's what it has here. So if you update the value of n, so if I change that and hit calculate, it'll automatically readjust the values of mu and sigma, the mean and standard deviation. Sometimes it does take a little bit of time for it to refresh the screen when redrawing these histogram bars, and that's just really because there's those histogram bars, there's a lot to be drawn and replaced and that sort of thing. So it's kind of an expensive computational thing. But that's how it's used.